In this video, we want to find a closed-form solution to the Towers of Hanoi problem, which is a classic problem that I've done a video on. I've probably put the link in the description or somewhere. But in this video, we want to find a way to write S sub n in terms of only n, not in terms of any previous terms, right? We want it to only be in terms of n so that we don't have to go through the first 7 terms in order to figure out what the 8th term is. We want to just be able to calculate only the 8th term. And so the way we're going to do this is we're just going to start building terms but not simplifying them and try to recognize a pattern. And then later in the next video, we'll actually prove that the pattern we found is a solution to this recurrence relation. So we're going to start out, we know the first term here, S sub 1 equals 1. And we know this recurrence relation, so we know that S sub 2 equals 2 S sub 1 plus 1. And so then we're going to continue. We're going to write S3, right? This is 2 times S sub 2, which is 2 S sub 1 plus 1 plus 1. So you see what we did there? We just took this recurrence relation, replaced the n's with 3's, right? S of S3, this is S2, but instead of writing S2, we took this whole thing and put it in here. And now I am going to distribute this just so that you can see here that this is 2 squared S1 plus 2 plus 1. Now we have S4, which is going to be 2 times S sub 3, which we found right here is 2 squared S1 plus 2 plus 1 plus 1. And then distributing that, we get 2 cubed S1 plus 2 squared, the 2 times the 2, plus 2 plus 1. And perhaps already you've begun to see a pattern. Let's do one more here. S sub 5 equals 2 times S4, which we just found to be 2 cubed, the first term, plus 2 squared, plus 2 plus 1 plus 1, equals 2 to the 4th, plus 1, plus 2 cubed, plus 2 squared, plus 2 plus 1. And so at this point, right, it's fair that we can take a guess here as to what we think S sub n is going to be, right? And so notice here in the 5th term, right, this power keeps increasing by 1, and it's always 1 less than whatever n we're on. So we're going to guess that this is 2 to the n minus 1, S sub 1, plus 2 to the n minus 2, plus dot dot dot, plus 2 plus 1, right? Where, you know, this is 1 power less than that, and you keep adding a power less than that, a power less than that, a power less than that, all the way down to 1. Now in this case, because our first term is equal to 1, we can put 1 in here. If our initial condition wasn't 1, our answer would be different, right? But since it's 1 here, that becomes a 1, and 2 to the power of n minus 1 times 1 is just 2 to the power of n minus 1. So this tells us that S sub n equals 2 to the n minus 1 plus 2 to the n minus 2 plus dot 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 plus 2 plus 1. And so now this looks maybe a little messy, but we can use an identity that we know to make this a little simpler. And this is just a mathematical fact that is true and that I may prove in another video. But for now, this is just something that is true. And so notice that we only go up to n minus 1 instead of n. So that means we're just subtracting 1 off of here, right? So instead of going up to n, we're only going up to a to the n minus 1. So this is only going to be, right, if you put an n minus 1 here, you have n minus 1 plus 1, right? So this just becomes a to the n minus 1 over a minus 1. These match exactly, except for the fact that instead of a, we have 2. So we're going to write this as S sub n equals 2 to the n minus 1 over 2 minus 1, but 2 minus 1 is just 1. So this is going to be 2 to the n minus 1. So this tells us that the number of moves it takes to move n disks in the Tower of Hanoi to another peg is 2 to the n minus 1. If we wanted to figure out, how many moves would it take us to move 4 disks, right? Then s sub 4 equals 2 to the 4th minus 1, which is equal to 16 minus 1 equals 15. And so it allows us to calculate any term in the sequence without knowing the previous terms.